Hi! Today we're going to learn about limiting reactants or limiting reagents. Let's say we have a problem like this. Calculate the mass of CCl4 created given 40 grams of CH4 and 450 grams of Cl2. And we have the equation CH4 plus 4Cl2 is equal to 4HCl plus CCl4. So the way I solve these problems, and the way that I prefer solving these problems, is by using a table that's close to a BCE table or ICE table. So the way I do it is I make a table as big as the equation, and then I isolate one box for each section of the equation. So we have the arrow here. And so these are represented in these boxes here. So in the first column, what we want to do is find the total number of moles that we have in the initial stage of the reaction. So the first thing that you know is you have 0 moles here in the beginning, and you have 0 moles here. So this is initial. So let's figure out how many moles of CH4 we have. So using our calculator, we find out we have 40 divided by, in parentheses, so we have C, which has a weight of 12, plus 4 times 1.007, so times, in parentheses again, 4 times 1.007, parentheses closed, and this gives us about 2.5 moles. So we have approximately 2.5 moles of this. Now let's figure out how many moles we have of 4Cl2. So we have chlorine, and by the way, chlorine is represented here as element number 17 with a weight of 35.453. So we have 4 times, or actually, sorry, the way we do it when we have a coefficient is we just ignore the coefficient and we find the number of moles that we have just given Cl2. The 4 will come into play later. So we have 450 divided by 2 times 35.453. And so this gives us 6.346. 6.346 moles. So once again, it's just 450 divided by 2 times 35.453. So the next thing that I do is, instead of creating the change in between, I do something that's sort of like a ratio. So this is the mole ratio between. So the next step that I do is just finding the mole ratios between each of the elements. But it's a little different than that. As you can see, the mole ratio between CH4 and 4Cl2 is 1 to 4. So we have basically a 1 to 4 to 4 to 1 ratio. So we can easily figure that out from this. But the thing that I put in this next column is, and let's just put an arrow up here instead. What I put, no, we don't even need an arrow. Whoops, sorry. So what I put in this next column, or next row, sorry, is I put the number of moles that we have of each element divided by the coefficient of this term here. So we have 2.5 divided by 1, which is 2.5. And then we have, and once again, we're just dividing the number of moles that we have by its coefficient, and we'll figure out why we need that later on, like in 30 seconds. So we have 6.34 divided by 4 to get 1.59 approximately. 1.59. And then 0 divided by 4 is 0, and 0 divided by 1 is 0. So why do we need to do this? And these are moles. So why do we need to do this? Well, this is to help identify which of these is the limiting reagent or reactant. So it helps identify which of these is the limiting reagent. So how does this help us? Well, we know that if we have 0.25 moles of CH4, then for this reaction to have no limiting reagents, both of them are completely consumed, then we need to have, according to the mole ratio of 1 to 4, then we need to have 2.5 times 4, which would become approximately 8 plus 2, which is 10. So 2.5 times 4, or 10 moles. So you would, if you had in the beginning 2.5 moles of CH4, then you would need 10 moles of 4, or you would need 10 moles of Cl2 for this reaction to go to completion with no reactants left over. But it gets a little bit more complex when you have the mole ratios with another value here. So let's say it was 5 to 4. So it gets a little bit more confusing. However, by dividing by the coefficient, you can just see whichever one is the smallest, and whichever one is smaller is the one that is a limiting reagent or reactant. So if this was 5, if this was 5 here, let's just say for the sake of this point, then we would have 2.5 divided by 5, which is 0.5. And we would know that because 0.5 is smaller than 1.59, it would have to be the limiting reagent or reactant. So it's simple that way. We just create this. We just create this extra row here that helps us figure out what the limiting reagent is. In this case, the limiting reagent is Cl2. And we also know that we have only 6.34 moles of Cl2. The other thing that this helps us with is the next step. So the next step is identifying the change. So in this case, we don't really care about what happens to, so we want to figure out what happens or how much of CCl4 is created, so we don't exactly care about what happens to this one here, or to this here. But let's still do them. So in this case we have minus 6.34 moles. All of them are being consumed. But how do we figure out how many moles are being consumed here? Well, it's simple. We take this number here for the limiting reagent and we multiply it by the coefficient of whatever we have of the one that we're trying to find. So I know that sounds a little daunting and confusing. So let's actually do it. So we take 1.59 and we multiply it with the coefficient here, which in this case is 1. So we get minus 1.59 moles. So over here we have 4. So we multiply 1.59 with 4 to get 6.34 moles. And then here we have this multiplied by 1 to get 1.59 moles. So now let me explain, and these are plus. Now let me explain why we needed to do that and why we used this value here. So this basically helps us with the mole ratios once again. So when we use 6.34 moles of this, and we're creating some amount of moles here, we look at the mole ratios to figure out how much we're creating. So to figure out how much we were creating of CCl4, we would divide 6.34 by 4, and then multiply it by the coefficient here, which is 1, because the ratio is 4 to 1. So, once again, we would just divide how many moles we had that we were using by 4, and then multiply that by 1. So let's say this was 4 to, instead of 1, let's just say there was a 5 there. So if we had a 4 to 5 mole ratio, we would have to divide 6.34 by 4, and then multiply it with 5. But it's simple because we already have this divided by the coefficient 4, which is 1.59. We just have to multiply this by 5, which we would realize would be the coefficient of that here. In this case, it's 4 to 1 ratio. 4 to 1 ratio. Okay, so now we have the last column. And the last column is really easy. In the last column, we just subtract and add the number of moles that we have. So in this case, when we get to this last column, the R row, or the last row, the R row doesn't exactly matter. So we have 2.5 moles minus 1.59 moles, and let's do that on the calculator to be sure. 2.5 minus 1.59 gives us 0.91 moles. You have 6.34 divided, or minus 1.59, or sorry. We have 6.34 minus 6.34, which is equal to 0 moles. You have 0 moles plus 6.34 moles, which is equal to 6.34 moles. And then you have 0 moles plus 1.59 moles, which is 1.59 moles. And so what we get from this last column here is we see that we have 0.91 moles of this first reactant remaining, and that we've created this many moles of the other ones. So now we have the last step. We have to calculate the mass of CCl4. So we do that just by multiplying the number of moles. So the number of moles times the molar mass. And we get that this is equal to 1.59 times, in parentheses, C, which is 12, plus Cl4, which is 4 times, in parentheses, 4 times Cl, which is 35.453. And so that gives us 244.56 grams created, or not created, grams of CCl4. So, today we learned about limiting reagents or limiting reactants. Thank you for watching this video. And by the way, limiting reagents and limiting reactants are the same thing. Thank you for watching this video.